Hi guys, welcome to this easy maths video, and today we're looking at the AQA GCSE Further Maths Paper 2 exam. This is a calculator exam and the time allowed is 1 hour and 45 minutes. Question 1. A sketch of the lines y equals 2x and y equals 6 is shown. Work out the area of the triangle OPQ. Okay, so what we need to do is we need to work out what each of the points represent. So point O, point P and point Q. We need to work out their coordinates. Now, point O, there's a slight mistake that they've made on this diagram. It doesn't actually show it going through the intersection of both the x and the y axis. So the line should actually be going through this point here. So that's the origin, so that's point 0, 0. And I know that because this line has the equation y equals 2x. So when x is 0, I also get a y value of 0. So it must pass through the origin. Now, to work out coordinate P, well, we know this is the point at which the line y equals 6 crosses the y-axis. So we know y is going to be 6, and of course x will be 0. So with the coordinate 0 is 6. So in other words, the line O to P is 6 units long. And to work out coordinate Q, this is basically the point at which the line y equals 2x and y equals 6 intersect. So what we can do is we can make these two equations equal to each other. So we get 2x equals 6, and then we can solve for x. So x is 3. So we know it's 3 units along. And then of course, because the point is on the line y equals 6, our y coordinate must be 6. So the length from the coordinate P to Q is 3 units. And the other thing I know is that the gradient of y equals 6 is perpendicular to the y-axis. So there's a right angle there. So now I've basically got a right angle triangle with a base of 3 and a height of 6. So I can work that out using my formula, a half times base times height. So if I do half, multiply by my base, which is 3, multiply by my height, which is 6. So I'm doing 3 times 6, which is 18. 18 times a half, which is 9 units squared. And that is my final answer. Question 2. A circle centre 0, 0 has circumference 2 pi. Work out the equation of the circle. Okay, so because we know that this circle has centre 0, 0, we know it's going to be in the form of x squared plus y squared. But of course that is equal to r squared, so we need to find out what the value of r is. We're not given the radius, but we are given the circumference of the circle. So if we use our formula for finding the circumference, which is 2 pi r, and make that equal to 20 pi, then we can just solve for r. So we can divide both sides by pi, so the pi's will cancel out, and then we can divide both sides by 2, so we get r equals 10. And then we can just substitute r into our equation here. So our formula is going to be x squared plus y squared is equal to 10 squared, which is 100. So that is the equation of our circle. Question 3. M is the midpoint of the line AB. Work out the values of P and R. Okay, so to work out the midpoint, what we need to do is we need to add the coordinates of the x coordinates of point A and point B, and then divide them by 2. And then we also need to do the same with the y coordinates. So what we can do is we can form two equations to work out what P and R are. So to find the x coordinate of the midpoint, we're going to do minus 2 plus the 7 divided by 2. And that's going to be equal to P. And then our second equation, looking at the y coordinates, we're going to do 3 plus r divided by 2 equals minus 1. And now we just need to solve these two equations to work out the value of P and R. So if we look at this first equation, minus 2 plus 7 over 2 equals P, we simplify the top, that's just saying 5 over 2 equals P. So that is our value for P, is 2.5, 2.5. To work out R, we can multiply both sides of our equation by 2, so we get 3 plus R is equal to minus 2. And then we can just subtract minus 3 from both sides. So we get r is equal to minus 5. That's question 3. Question 4, part A. Circle the solution of minus 3x is less than minus 18. All we have to do is just divide this inequality by minus 3. So what we're going to get is we're going to get x is less than, and then minus 18 divided by minus 3, which is 6. So it must be that answer there. Now this one's a bit trickier. The way I would think about this is I would minus 16 from both sides, and I say that we've got x squared minus 16 is greater than or equal to 0. I know to solve this, it's the difference of two squares, so I'm going to end up with an inequality in the form of x plus 4 and x minus 4 is greater than or equal to 0. And then I can draw a little sketch of this to show which way my inequality sign should be going. So I know that point's minus 4, that point's 4. So basically what I'm saying with this inequality is I'm saying for what values of x is y greater than or equal to 0. Because that's what this is. If you imagine it as an equation, x plus 4 all multiplied by x minus 4 is just our function. For the values of x, where y is greater than or equal to 0, it's going to be the points where the curve is above the x-axis. So it's these shaded regions here. So in other words, if this is minus 4, then x has to be less than or equal to minus 4. If this is 4, x must be greater than or equal to 4. So it's got to be this one here. Question 5. Here is a sketch of y equals function x, where function x is a quadratic function. The graph intersects the x-axis at point A, minus 1, 0, and B. It has a maximum point at 0.56. Work out the coordinates of B. This question is basically just testing us to see whether we know that a quadratic function is symmetrical, and it is. A quadratic function is symmetrical about its maximum or minimum point. In this case, we've got a maximum point. So the maximum point is going to be here, and we know that's 0.56. So if I draw a line of symmetry going through this point, well, what I can think of now is point B is just a reflection of point A in the line of symmetry. And I know what point A is. I know point A is minus 1, 0. So I need to think, well, how many units along the x-axis do I need to get from minus 1 to 0.5? Well, that's 1.5, so I need to go across the x-axis 1.5 units to get to the line of symmetry. In order to reflect it, I'm going to need to go along another 1.5 units. So this is going to have an x-coordinate of 0.5 plus the 1.5, which is 2. And then, of course, because it's crossing the x-axis, my y-coordinate must still be 0. So my answer is 2, 0. Now part B says the equation f of x equals k has exactly one solution. Write down the value of k. Okay, so we're basically finding the intersection of the two equations y equals f of x and y equals k. Now we don't know what this value of k is. It's basically a line that is parallel to the x-axis, but we're told that the intersection of these two equations only has one solution. And the point at which it only has one solution, because it's a quadratic curve, is at its maximum point. If I were to draw the line y equals k, it would have to be at the maximum point, because that is the point at which I only have one solution. I only have one x-coordinate and I only have one y-coordinate. So y is 6 at this point, so therefore k is going to be equal to 6. So k will equal 6. Question 6, we've got a matrices question. We've got the matrices A, B, C and D. We're told S, T and U are constants. And then in part A we're also told that matrix A multiplied by matrix B equals matrix C. And we've got to work out the values of S and T. So if we take matrix A, we're doing 4 minus 1 minus 7, 2, multiplied by B, which is S minus 5, which is equal to C, which is minus 1, T. Okay, so what we know is that this is a 2 by 2 matrix. This is a 2 by 1. And this is a 2 by 1. So we know that when we multiply these two matrices together, we're going to get 2 by 1 matrix. Okay, so to multiply these two matrices together, what we need to do is we need to do the 4 multiplied by the S. We get 4 s, and then the minus 1 multiplied by the minus 5, so that's going to be plus 5. And then we're going to need to do the minus 7 multiplied by the s, so that's minus 7s, plus the 2 multiplied by the minus 5, so that's minus 10. And that is all equal to minus 1t. So now what we can do is we can create two equations in terms of s and t. So we're going to have 4s plus 5 is equal to minus 1, and minus 7s minus 10 is equal to t. So we solve for s first, minus 5 from both sides, we're going to get 4s is equal to minus 6. So s is going to equal minus 6 over 4, which is the same as saying minus 3 over 2. So that's our value for s, so that's minus 1.5. And now we need to work out t. Well, we can work out t by substituting s into the second equation. So we're going to get minus 7 multiplied by minus 3 over 2. Well, minus 7 times minus 3 is 21, and 21 divided by 2 is 10.5. So we're actually doing 10.5 minus 10 equals t. So t must be equal to 0.5. And that is our answer for part A. And then part B says A multiplied by D is equal to I. Now I is our identity matrix. So we use A, which is 4 minus 1 minus 7, 2. And then multiply that by D, which is 217u. We need to work out the value of u. And this is equal to our identity matrix, which looks like this, 1, 0, 0, 1. Okay, the identity matrix is something that you have to remember. That is what it looks like. So what we've got is we've got two 2 by 2 matrices. And if we multiply them together, we are left with another 2 by 2 matrix. So to work this out, we're going to need to do the 4 multiplied by the 2, which is 8, plus minus 1 times 7, which is minus 7. So 8 minus 7 is 1. Then we're going to do 4 multiplied by the 1, which is 4, minus u. So we get 4 minus u. Then we do the minus 7 multiplied by the 2, which is minus 14, plus 2 times 7, which is 0. And then we do the minus 7 times the 1, which is minus 7, plus 2 times the u. So we get minus 7 plus 2u. Now what we can say is that this is equal to 1, 0, 0, 1. And of course we've got two equations in terms of u where we can use any of them to work out the value of u. I'm going to use that top one and say that 4 minus u is equal to 0. So u must therefore equal 4. Now that should be my answer, but what I'm going to do is I'm just going to double check that by multiplying it into the second equation. So what I get is I get minus 7 plus 2 multiplied by 4. 2 times 4 is 8. Minus 7 plus 8 is 1. So therefore I know u must be 4. Question 7. Work out the equation of the straight line that's parallel to the line 2y equals x and intersects the x-axis at 4, 0. Okay, so when I think of an equation parallel to a line, what I need to do is I need to think about its gradient. So to work out the gradient of the line 2y equals x, I need to get it in the form of y equals mx plus c, where m is our gradient. So what I can do is I can divide both sides by 2. So I get y equals a half of x. So a half is my gradient of this line, and my y-intercept is just 0. Okay, in other words, it passes through the origin. So my y-intercept is 0. In other words, it passes through the origin. So I know that my equation is going to have this gradient. So what I can do now is, because I'm also told that it intersects the x-axis at 4, 0, I can use this equation, y minus y1, which is going to be 0, y1 is 0, x1 is 4, is equal to m, which is my gradient, multiplied by x minus x1. So if I substitute these values in here, I can then work out an equation which passes through the coordinate 4, 0 and has a gradient of a half. So it's going to be y minus 0 is equal to m, which is a half, multiplied by x minus 4. So I'm going to get y is equal to, if I expand this bracket out, I get a half of x minus 2. So y is equal to a half of x minus 2. That's question 7. Question 8, part A, we need to work out AB over CD divided by BC over AD. Give your answer as a fraction in its simplest form. When we've got one fraction divided by another fraction, in order to simplify that, we take the first fraction and multiply it by the reciprocal of the second fraction. So what we're going to have here is we're going to have AB over CD multiplied by the reciprocal of BC over AD. So that's going to be AD over BC. Now, if I group these terms together, I'm going to have AB times AD. So that's going to be A squared BD over C squared times B times D. And what you should be able to see here is that the B and the D cancel out. So you're just left with A squared over C squared. So that is our answer for part A. And in part B, we need to work out 7 over 2x squared plus 4 over 3x. Okay. So what we need to do is we need to find a common denominator between both of these fractions. So we're going to have the 2x squared multiplied by the 3x. So we're going to end up with a denominator of 6x cubed. Okay, so what I've got to do is, because I know my denominator's got to be 6x cubed now, I need to rewrite each of these fractions with a denominator of 6x cubed. So for 7 over 2x squared, I'm going to need to multiply both the top and bottom of this fraction by 3x. So 7 times 3x is 21x, and that's going to be over 6x cubed. And I need to do the same for 4 over 3x. But rather than multiplying it by 3x, I'm going to multiply it by 2x squared, because that's what gives me a denominator of 6x cubed. So 2x squared times 4 is 8x squared, and then of course my denominator is 6x cubed. So if I simplify this, I can just add the numerators now. So I get 8x squared plus 21x all over 6x cubed. Now, because we've got to give our answer in its simplest form, what we can do is you should be able to see that there's a factor of x we can take out from both the numerator and the denominator. So we can actually simplify this to 8x plus 21 over 6x squared. And that is going to be our final answer. Question 9, A, B and C are points on a circle with centre O. We need to work out the size of angle Y. So the first thing you've got to do here is you should be able to spot a circle theorem. And the circle theorem is that the angle at the centre is twice the angle at the circumference. So what we're basically saying is because our angle at the centre is x plus 62, and that is equal to twice the angle at the circumference, which is 2 times 2x minus 50. So we now got one equation in terms of x, and we just need to solve for x. So we're going to add x plus 62, expand this bracket out, we're going to have 4x minus 100. And then what I can do is I can minus x from both sides, so I'm going to get 62 is equal to 3x minus 100. And then I can add 100 to both sides, so I get 162 is equal to 3x. Now I can work out my value of x by dividing both sides by 3. So 162 divided by 3 is 54. Okay, so how am I going to work out y? Well, if I have a look at this diagram, what I've got is I've got a triangle OBC. There's something quite special about this triangle. Because O to B and O to C are my radius of the circle, because it's going from a centre to the point on the circumference, then because I know that both of these lines are the radius of my circle, then I know that they must be equal. And if both of these lines are equal, then both this angle and this angle must be equal. So if angle OCB is equal to y, angle OBC must also be equal to y. And now, of course, I know that there's 180 degrees in a triangle, and I've got my value of x, which is 54. So first I can work out what angle BOC is. So if I say angle BOC, well that's just going to be equal to 54 plus 62, which is 116. And then to work out y, well, I know I've got two angles that are equal. So the total of those two angles are going to be equal to 180 minus 116. So 180 minus 116 is equal to 64. And I'm basically saying that 2y is equal to 64. So I can now divide both sides of this equation by 2 to get my value of y. So y is 32. Question 10. Y equals 6x to the power 9 plus x to the power of 8 all over 2x to the power of 4. We need to work out the second derivative when x is equal to 0.5. So first thing you're probably wondering is, how am I going to differentiate this equation? At GCSE Further Maths, I don't have any skills to differentiate a fraction like this, but what I can do is, rather than treating this as one whole fraction, I can separate it into two fractions. So I can write this as y equals 6x to the power 9 all over 2x to the power of 4 plus x to the power of 8 all over 2x to the power of 4. And now, using my laws of indices, I can simplify these powers of x. So what I can do is I can do the 6 divided by the 2, which is 3, and then I'm going to have x9 divided by x to the power of 4. So that's going to be x to the power of 5. And then I'm going to have plus a half of x to the power of 8 divided by x to the power of 4. So that's going to be x to the power of 4, because I'm going to subtract the powers. So we're going to need to differentiate this function. So we get dy by dx is equal to 5 times 3, which is 15, x minus 1 from the power, x to the power of 4, plus 2x cubed. Second derivative, we're going to need to differentiate it again. So we get 15 times 4, which is 60, x cubed, plus 2 times 3, which is 6, and then x squared. Right, and we need to work out the value of this second derivative when x is equal to 0.5. So we say when x is equal to 0.5, second derivative is going to be equal to 60 all multiplied by 0.5 cubed plus 6 all multiplied by 0.5 squared. So we type that in on our calculator. We get an answer of 9. So that is our final answer. Question 11. For sequence A, the nth term is n over 14n plus 30, and sequence B, the nth term is 2 over n. We're told that the kth term of sequence A equals the kth term of sequence B. Work out the value of k, you must show your working. Okay, so I know what the nth term of both sequence A and sequence B are. So to work out the kth term, I've just got to replace n with k. So sequence A is going to be k over 14k plus 30. And I know that this is equal to the kth term of sequence B. So that's going to be equal to 2 over k. So now what I need to do is I need to solve this equation and work out my value of k. So what I'm going to do first is I think I'm going to multiply both sides of my equation by k. So I'm going to get k squared over 14k plus 30 is equal to 2. And now I can multiply both sides of my equation by 14k plus 30. So I get k squared is equal to 2 multiplied by 14k plus 30. If I expand this bracket out on the right hand side, I can get k squared is equal to 28k plus 60. And then if I subtract the 28k and the 60 from the right hand side, move that over to the left hand side, I've got a quadratic equation in terms of k. Now what I can do is I can factorise this, because I know I've got factors of 30 and 2. So what I could say is I'm going to have k plus 2 and k minus 30. And I know that the 2 minus the 30 is going to give me minus 28, so that works. You could use the quadratic formula, that's absolutely fine, but it's always good to test whether there's any factors of 60. It ends up being a lot easier and a lot more quicker to simplify. So that's all equal to 0. So now I know that k is equal to minus 2 or 30. We're talking about sequences here where we've got different terms, so that we're trying to work out the kth term. Well, you can't have a negative term in your sequence, so our value of k must be 30. So k is equal to 30. Question 12. This shape is made from two rectangles. All dimensions are in centimetres. We're told that the perimeter of the shape is 252 centimetres, and we need to show that y is equal to 126 minus 45x. Okay, so to work out the perimeter, we need to add up all of the side lengths of this shape. Now, there's one length that we're missing from this diagram, and that's very easy to work out because we know that, of course, this side length is equal to this side length plus this side length. So, of course, that's just going to be 15x plus y. And I know that the perimeter is equal to 252, so if I add up all of these lengths, I'm going to get 30x plus 15x plus 10x plus y plus 20x plus 15x plus y is equal to 252. So I need to simplify my x terms and my y terms. So if I do 30 plus 15 plus 10 plus 20 plus 15, I get 90x. And then I've just got a y plus a y, which is 2y. And that's equal to 252. Now part A has told me to show that y equals 126 minus 45x. So I need to rearrange this to get y as my subject. So I've got 2y is equal to 252 minus 90x. And I should be able to get my value of y by dividing both sides of this equation by 2. So I'm going to get y equals 252 divided by 2, which is 126, and minus 90x divided by 2, which is minus 45x. And that is what we had to show. Part B says the area of the shape is a centimetre squared. We need to show that a equals 2520x minus 450x squared. Okay, so for this, I am going to need to divide the shape into two rectangles. Because if I say that this is area 1 and this is area 2, and I can work out each of these areas and then add them together. So area 1 is equal to 30x times 15x. 450x squared. And area 2 is equal to 20x times y. So I just get 20x y. But I know in the first part of the question that y is equal to 126 minus 45x. So I can just replace y with 126 minus 45x. So I get 20x multiplied by 126 minus 45x. Simplify that. I'm going to get 20 times 126, which is 2520x minus 45 times 20, which is minus 900x squared. And then to work out a, the total area, we do 450x squared plus 2520x minus 900x squared. And of course that simplifies to 2520x minus 450x squared. And that's what we had to show. Part C says use differentiation to work out the maximum value of a as x varies. So what we're doing now is we're treating this equation of a as a function of x, and we've got to find the maximum value of this equation. So we've got a equals 2520x minus 450x squared. If we differentiate this, so we're going to do dA by dx, we're going to get 2520 minus 2 times 450, that's 900x. So if we work out the maximum value, if we make dA by dx equal to 0, we'll get 2520 minus 900x equals 0. And we can work out x by saying that 2520 divided by 900 equals x. So that gives us an answer of 2.8. And then to work out the maximum value of A, we can just substitute 2.8 into our original equation for A. So we get A equals 2,520 multiplied by 2.8 minus 450, all multiplied by 2.8 squared. We put that into our calculator. We get 3,528. Question 13. Function x is equal to 3x squared plus 6 for all values of x. Function g of x is equal to the square root of x minus 5, where x is greater than or equal to 5. We've got to work out the value of the composite function of g of f, all multiplied by 4. So, what we need to do first is we need to work out the composite function of g function x. So to work that out, we need to replace x in root x minus 5 with 3x squared plus 6. Plus 6 minus 5. And this simplifies to 3x squared plus 1. Okay, so now we can substitute 4 into this formula to get our value. So we get 3 multiplied by 4 squared plus 1, all square rooted. 4 squared is 16, 16 times 3, 48, plus 1 is 49, square root of 49 is 7. So that is our answer for part A. Part B is to show that the function of g of x can be written in the form a multiplied by x minus a, where a is an integer. So f g of x is the same as taking function x and replacing x with root x minus 5. So we get root x minus 5 all squared plus 6. Now, and if we square root x minus 5, we get 3 multiplied by x minus 5 all plus 6. Function g of x is equal to 3x minus 15 plus 6, and that is equal to 3x minus 15 plus 6 is minus 9. Now we need to show that it can be written in the form of a all multiplied by x minus a. So if you take out a factor of 3 all multiplied by x minus 3. So we can say our answer is 3 all multiplied by x minus 3, where a equals 3. That's question 13. Question 14. Use the sine rule to work out the size of obtuse angle x. So what I'm going to do is I'm going to call this side angle A, that angle B, that angle C. So this is going to be have a side lowercase a, lowercase b, lowercase c. And using the sine rule, because we're trying to work out an angle, we can say that sine x all over 2y is equal to sine 18 all over y. And now we can solve for x. So if you multiply both sides by 2y, you get sine x is equal to 2 sine 18. Now we can just find what x is by doing the inverse sine of 2 sine 18. So if I type that in on my calculator, I end up getting x is equal to 38. I'm going to do 0.17 degrees to 2 decimal places. But I'm told I have to work out the obtuse angle of x. Now, an obtuse angle, as you should be able to see in the diagram, is an angle that's greater than 90 degrees, but less than 180. Well, 38.17 is not greater than 90. So, what we need to do, either using the car circle or the graph of sine x, I'm going to use the car circle. So if I use the car circle, I know that's going to be 38.17, and if we look at sine x is also going to have another value of 180 minus the answer we got. So, or x can equal 141.83 degrees. That's to 2 decimal places. So what I'm going to do is I'm going to round it up to 3 significant figures. So I'm going to say x is equal to 142 degrees. And that's my answer for question 14. Question 15, here is a sketch of the curve y equals ab to the power minus x, where a and b are positive constants. We've got coordinates 0, 3 and 2, 0.48 lie on the curve. Work out the values of a and b. Okay, so what we can do is we can substitute these two coordinates into the formula y equals ab to the power minus x, and then we should be able to solve simultaneously for a and b. So first point is 0, 3. So we replace y with 3, and then we're going to have a b to the power of minus 0, so that's just going to be 0. And of course b to the power of 0 is 1. So we actually get a value for a straight away. A is 3. Okay, so using that information, we can substitute the point 2, 0.48 into the equation to work out our value for b. So we replace y with 0.48. And then we've got a, which is 3, multiplied by b to the power of minus 2. Now, what can we do? We can divide both sides of this equation by 3. So we get 0.48 divided by 3, which is 0.16 equals b to the power minus 2. Now, this is the same as saying 0.16 is equal to 1 over b squared. And what I can actually do is I can flip over the fractions, so I can actually say that b squared is equal to 1 over 0.16. So I get 1 over 0.16 is equal to 6.25. And then I've just got to do the square root of 6.25 to work out b. So b is equal to plus or minus 2.5. But of course, because the curve is going in this direction, we know that b has to be positive. So b will just equal 2.5. So a is 3 and b is 2.5. So that's question 15. Question 16. Simplify 8x cubed minus 50x all over 2x multiplied by 6x squared minus x minus 35. Give your answer in the form ax plus b all over cx plus d, where a, b, c and d are integers. Okay, so how are we going to go about doing this question? I'm going to try and simplify both the numerator and the denominator and see where we get to. So, we've got 8x cubed minus 50x all over 2x multiplied by 6x squared minus x minus 35. So first thing we can do is we can take out a factor of x. Okay, I think that's probably going to be the best thing to do. Because if we expanded this bracket out on the denominator, every value is going to have a term of x. So we can rewrite this as 8x squared minus 50 all over. Now, and if I expanded this, that would be 12x cubed. So I'll get 12x squared instead. Minus 2x squared, so I'm going to minus 2x. And then that's going to be minus 70. Now, the other thing I can do is I can then divide through by 2, because every value is even. Okay, so I'm going to get 4x squared minus 25 all over 6x squared minus x minus 35. What I can see now is the numerator. I can see we've got a difference of 2 squares. We've got 2x plus 5 and 2x minus 5. So now we've got to think, well, how are we going to simplify our denominator? Well, it's a quadratic function. So what I'm going to try and do is I'm going to try and use the factors of 5 and 7. So we simplify this and say that we've got a 2x and a 3x to give us the 6x squared. And then what could we do? We could multiply the 5 by the 3x and then subtract the 7 multiplied by the 2x. That'll give us the minus x. So if we make this plus 7 and this minus 5, then we get 2x times 3x, which is 6x squared, plus 14x minus 15x. That gives us the minus x. And then we get the minus 35. So that does work. So therefore we can rewrite this as 2x minus 5 multiplied by 3x plus 7. And now what we can do is you should be able to see that the 2x minus 5s cancel out. And we are left with 2x plus 5 over 3x plus 7, which is in the form ax plus b over cx plus d, where a, b, c and d are different integers, because we've got a as 2, b as 5, c as 3 and d as 7. So that is our final answer. 2x plus 5 over 3x plus 7. Question 17 says, by multiplying both sides of the equation by x to the power of a half, solve 2x to the power of 3 over 2 minus 3x to the power of a half is equal to 7x to the power of minus a half for x greater than 0. Give your answer to 3 significant figures. You must show you're working. So let's see what happens to this equation when we multiply both sides by x to the power of a half. So we're going to have x to the power of a half multiplied by 2x to the power of 3 over 2 minus 3x to the power of a half is equal to 7x all to the power minus a half multiplied by x to the power of a half. Okay, now in the bracket on the left hand side, what happens is we end up just adding the powers, because it's laws of indices. If you multiply two numbers with the same base, so we've got both of our bases in terms of x, we can add the powers. So we're going to have 2x to the power of half plus 3 over 2. Well, that's the same as saying 4 over 2, which is just 2, so we get 2x squared minus 3x. Now that is equal to 7x to the power of a half multiplied by x to the power of a half. Well, you're adding the powers, so you do minus a half plus a half, which is 0. So you get 7x to the power of 0, or x to the power of 0 is 1. So that just equals 7. And now, if we minus 7 from both sides, we've got this as our quadratic equation. Now to solve it, the question says we've got to give our answer to 3 significant figures. So I think we're going to have to use the quadratic formula for this one. So if I say a is 2, b is minus 3, and c is minus 7, I can say that x is equal to minus b, which is minus 3, so that's going to be 3 plus or minus square root of b squared, which is minus 3 squared, which is 9, minus 4 times 2, so 2a, so 4ac, multiplied by minus 7, all over 2 times 2. So if we simplify this, we get 3 plus or minus. Now I'm just going to type that into my calculator. And I get the square root of 65, and that's over 4. So I'm going to get x equals 3 plus root 65 over 4, or x equals 3 minus root 65 over 4. So if I type in those values on my calculator, the first answer is positive and the second answer is negative, okay? And I'm told in the question that we want only x values that are greater than 0, so we only want positive x values. So therefore, we're only going to have our first answer, which is equal to 3 significant figures. So x will equal 3 plus root 65 over 4 to 3 significant figures is 2.77. And that's question 17. Question 18, how many odd numbers greater than 30,000 can be formed from these digits 2, 4, 6, 7, 8 with no repetition of any digit? Okay, so for this we have to use something called the product rule for counting. Now, what we basically do here is we try and think of all the possible numbers we could come across, and then we work out how many different combinations of each of those numbers we can produce. We've got 5 digits, so let's say we've got 5 spaces. Now, we're told in the question that our number is going to be odd and it's got to be greater than 30,000. So the first thing is we've got to work out how many odd numbers are greater than 30,000. Well, if we look at these digits, there's only one number that is odd, which is the 7. So that means the 7 has to be in this column here. If we say this is our units column, this is our tens, this is our hundreds, this is our thousands, this is our tens of thousands, then the 7 is going to be in a fixed position in the units because it's the only digit that's odd and we have to form odd numbers. Now let's have a look at the other numbers. We're also told that our numbers have to be greater than 30,000. So that means in this first column, the 10,000s column, we can't have the number 2. So let's think of all the other different combinations we could have. Well, we could have a 4. We could have a 6. We couldn't have the 7 because that's in the units column, but we could choose the 8. So we've got 3 different combinations for 10,000. So I'm going to write 3 down here. And let's say for argument's sake we end up using the 4. So I'm just going to put a 4 in the 10,000s column, just so it makes it a little bit easier to explain what we have to do next. So now if we look at the thousands column, well, we can now choose the 2 because we couldn't include the 2 in the first column because we had to choose a number that was greater than 30,000. Okay, so that means we can choose the 2. We can't choose the 4 because we've already used that in the 10,000 column. We can choose the 6. We can't choose the 7 because that's in our unit column, but we could choose the 8. So again, we've got another 3 possible combinations. Now, because I said this method is called the product rule for counting, we multiply our combinations together. So we're going to do 3 times 3. And then let's say for argument's sake, we end up using the 2 in our thousands column. Okay? Now we'll look at all the different combinations in the hundreds column. Can't choose a 2 or a 4 because they've already been used. Could choose a 6. Can't choose a 7, that's in the units column, so we could choose an 8. So there's 2 combinations for the hundreds column. So we multiply that by 2, and let's say we use the 6. And now we've only got one number left over, which is the 8. So the 8 has to go in here, and that means there's only one combination. So to work out the total number of digits that can be formed, we multiply all of the combinations together. So 3 times 3 times 2 times 1, which is 18. So therefore, 18 odd numbers greater than 30,000 can be formed with no repetition of digits. Question 19, function x is equal to 3x cubed minus 2x squared minus 7x minus 2. Part A says use the factor theorem to show that 3x plus 1 is a factor of function x. To show that 3x plus 1 is a factor, we say that a solution of the equation will be x equals minus 1/3. Because we're basically saying that 3x plus 1 is equal to 0, and then we're solving for x. And then what we do is we can substitute this value of x into our equation for function x. And if function x ends up equaling 0, i.e. where the curve crosses the x-axis, then we know that 3x plus 1 must be a factor. So if we substitute x equals minus 1/3 into f of x, we get 3 multiplied by minus 1/3 all cubed, minus 2 multiplied by minus 1/3 all squared, minus 7 multiplied by minus 1/3 minus 2. So if we type this into our calculator, I end up getting an answer of 0. So I can say f of x equals 0. Therefore, 3x plus 1 is a factor of function x. Now part B says factorise f of x fully. Okay, so we know we've got 3x plus 1 as a factor. Because we've got a linear term, and we know f of x is a cubic function, we know that we're going to have a linear term multiplied by a quadratic term to give us a cubic function. So to do that, to work out what the quadratic function is, we're going to have to use polynomial division. So we're basically working out whether 3x plus 1 goes into the equation 3x cubed minus 2x squared minus 7x minus 2. Okay, so we do the 3x cubed divided by the 3x, which gives us x squared. We'll write that on top. Then do the x squared multiplied by the 3x, so we get 3x cubed. And then do the x squared plus the 1, so we get plus x squared. We then rule this off, and then we subtract each of the terms. So we do 3x cubed minus 3x cubed, that's 0. And then we've got minus 2x squared minus x squared, which is minus 3x squared. And then we bring down the minus 7x and the minus 2. And then we say that minus 3x squared divided by 3x is minus x. And then we do minus x times minus 3x, which is minus 3x squared. And then minus x times minus 1, which is just minus x. Rule that off, subtract those two terms. Minus 3x squared plus 3x squared gives us 0. Minus 7x plus x is going to give us minus 6x. Then we can bring down the minus 2. And then we can do the minus 6x divided by the 3x. So we get minus 2. Then we can multiply the minus 2 by the 3x. We get minus 6x. And then we can multiply the minus 2 by the 1. We get minus 2. rule that off, and of course this simplifies to nothing, so we have no remainder left over. So therefore f of x, we can say, is equivalent to 3x plus 1 multiplied by x squared minus x minus 2. Okay, so that is f of x factorised into a linear term and a quadratic term. But the question does say to factorise f of x fully. And what that means is to put it in its simplest form as possible. So we should be able to get 3 linear terms by factorising the quadratic term to get 2 linear terms. Okay, so we factorise this quadratic term, we're going to have factors of 2 and 1, and that is going to end up simplifying to x minus 2 all multiplied by x plus 1. Because if we expand this, we get x squared plus x minus 2x, which gives us minus x, and minus 2 times 1, which is minus 2. So that factorises. So therefore, 3x plus 1 multiplied by x minus 2 multiplied by x plus 1 is function x in its fully factorised form. So this is our final answer. Question 20. VABCD is a pyramid with a horizontal rectangular base ABCD. V is directly above the centre of the base. VA is equal to VB, which is equal to VC, which is equal to VD, which is equal to 10 centimetres. AB is equal to 8 centimetres and BC is equal to 6 centimetres. M is the midpoint of BC, and we need to work out the size of angle VMD. Okay, so let's label the sides and the angle we're trying to find out on this diagram. So the angle we're trying to find is VMD. So that is this angle here. It's the angle between the 2 dotted lines. Now we know that AB is 8 centimetres. And we know that BC is 6 centimetres. So this side length is 6 centimetres. And we know M is the midpoint of BC. So C to M is going to be 3 centimetres. And M to B is also going to be 3 centimetres. Now, because we're told that the base ABCD is a rectangle, the length CD is also going to be 8 centimetres, and then the side length of AD is also going to be 6 centimetres. Now, how are we going to find the angle VMD? Well, what we're going to need to do is, let's think about the triangle VMD. And I'm going to draw that on here. So that's V, that's M, and that's D. This is the angle we're trying to find. Now, at the moment, we know that VD is 10 centimetres, so we can draw that on our diagram. This is going to be 10 centimetres. We don't know what DM is, or we don't know what VM is. But if we look at this diagram, we can figure out what the length of DM is by using Pythagoras' theorem. Because if we look at the triangle DMC, which I'll draw here, so that's D, that's M, and that's C. We know DC is 8 centimetres, and MC is 3 centimetres. And MC is perpendicular to CD. So we can use Pythagoras' theorem to work out the length of MD. So MD equals the square root of 8 squared plus 3 squared. Put that into our calculator. Get square root of 8 squared plus 3 squared, which equals root 73. So that's that length there. And then if we look at our triangle VMD, that is going to have a side length of root 73 centimetres. Currently, we've got 2 side lengths on the triangle VMD, and we need to find an angle. We don't know any of the other angles, so we can't use the sine rule. So it looks like we're going to have to use the cosine rule. But in order to find out one angle using the cosine rule, you need to know what all 3 sides are. Okay, because the formula for finding an angle using the cosine rule, in this case it's going to be cos m is equal to v squared plus d squared minus m squared over 2vd. Okay, that is basically what we're working out. But of course, if we say this is lowercase v, this is lowercase m, and this is lowercase d, we don't know what that value of d is. So if we look at this diagram again, well, what if we look at the triangle VMC? You should be able to see that the dotted line VM is perpendicular to the line BC. So there's going to be a right angle here. So we draw that triangle down here. We know that's V, that's M, and that's C. We've got a right angle there. Well, V to M is what we're trying to find. We know M to C is 3. And we're told in the question that VC is 10. So this must be 10. So using Pythagoras, we can say that Vm is equal to the square root of 10 squared minus 3 squared. If you type that in on your calculator, we get root 91. And now we can add that to this diagram. So this is going to be root 91 centimetres. And now we've got all of our side lengths for this triangle, so we can work out angle M. It's going to be cos M is equal to 73 plus 91 minus 100 all over 2 times root 73 times root 91. So if you type that in on your calculator, you get 73 plus 91 minus 100 all over 2 times root 73 times root 91. And I get an answer of 0.3926 to 4 decimal places. But if you just do the inverse of cosine and then press the answer button on your calculator, we should get that M is equal to 66.9 degrees to 3 significant figures. And that is my final answer. Question 21. Show that 2m plus 3 all cubed plus n cubed is divisible by 9 for all integer values of n. So first we need to expand the bracket 2m plus 3 all cubed. So that's the same as saying 2n plus 3 multiplied by 2n plus 3 multiplied by 2n plus 3 plus the n cubed. We expand two of these brackets. We get 4n squared plus 6n plus 6n plus 9 multiplied by 2n plus 3 plus the n cubed. Simplify that first bracket, we get 4n squared plus 12n plus 9 multiplied by 2n plus 3 plus n cubed. Expand this quadratic term with this linear term. We get 8n cubed plus 12n squared plus 24n squared plus 36n plus 18n plus 27. And then of course we've got this plus n cubed on the end, so I'm just going to add that here. So now if we simplify this, we get 9n cubed plus 36n squared plus 36 plus 18 is plus 54n plus 27. Now, if all of the terms in this equation are divisible by 9, then we've proven that this equation is divisible by 9 for all integer values. So if we factorise 9 out, we get n cubed plus 4n squared plus 6n plus 3. And therefore, we've proven that 2n plus 3 all cubed plus n cubed is divisible by 9 for all integer values of n. Thanks for watching the video, guys. Don't forget to subscribe to my channel. I've also left a link in the description to my website so you can download both the exam paper and the mark scheme from this video. And you can also check out any other videos from my YouTube channel on this page.